Now, how do we find the determinant of the matrix? Let's imagine we got a matrix A. The matrix A, let's talk about 2 by 2 first. So this is a 2 by 2 matrix. Let's say the matrix A is A, B, C, D, where A, B, C, D are the elements of the matrix. Yeah, these are known as the element of the matrix. Now, to find the determinant is written either the question is that, and then it says find determinant, find A, and then there are two lines which represent determinant, or it's like this, det dot A. Yeah, so that's another thing. So either it can be like that or det dot A. They both are same. They're asking about the same thing. How do you find the determinant? So you go for A. First you write it like that, and then instead of the square bracket you put that thing in that modulus lines, straight lines. Now then what we do is, are you right-handed, left-handed? All of you are right-handed? Yeah, okay, so it makes easy. If you're right-handed, this is what you do. You multiply these two together. Yeah, what's the answer? Answer is A times D, which is AD, and then always a minus in the middle, and then you do BC. Yeah, if you're left-handed, you still follow the same procedure. Yeah, now let's do example using this rule. Let's do an example. Let's imagine we got a matrix A. The matrix A is 3, 2, 5, 7, and I want you to find the determinant of this matrix. So the question is, find determinant of A or A determinant, whichever. So what you do, you draw the line, you write down 3, 5, 2, 7, you multiply these one together, 7 times 3, which is 21, minus, you multiply these one together, 5 times 2, which is 10. So the answer is 11. Okay, now as a practice, I'd like you to try finding the determinant of these matrices. Okay, now let's say we got a 3 by 3 matrix, and how do you find the determinant? Let's say these are A, which is a 3 by 3 matrix. 1, 2, 3, 4, 5, 6, 7, 8, 9. Yeah. So I choose some random numbers. So let's imagine I want to find out the determinant. The question is, find the determinant of this matrix. Now to find the determinant, first I will write down as in this form, A determinant. And then I will put this thing 1, 4, 7 here. I put 2, 5, 8 here. 3, 6, 9 here. Then obviously I cannot use the ABCD method because there are more elements. So to find the determinant, this is what I'm going to do. This one, I copy this one here and just put a box there. Yeah. This is whatever this number is, I need to change the sign. So now I put -2 here and put these two signs. I will explain in a minute. And this number, same, +3. So what we do is we alternate. Whatever sign is here, I copy the same. But whatever is here, I change it. If it's -2, I do +2. But this was luckily +2, so I have to do -2. Whatever that is, I just copy it. Yeah? And then I just put these two boxes. Then what I do is I do something like this. This is 1. So imagine Super Mario. We're playing Super Mario. So this is Super Mario who is here, and he can only walk that way and he can go that way. He's not allowed to walk diagonal. So you cover these things, the one he can walk. So what's left? 5, 6, 8, 9. So this 5, 6, 8, 9 will come here. 5, 6, 8, 9. Yeah, happy with that? So you got 5, 6, 8, 9 here. 5, 6, 8, 9. I will copy that one. Let me undo this Super Mario thing. Oh, sorry, Control Z. 5, 6, 8, 9. 5, 6, 8, 9. Yeah, happy with that? Now the Super Mario is at number 2. That's it. So he can see here and he can see here. So what's left? 4, 6, 7, 9. Yeah, 4, 6, 7, 9. So let's do Super Mario again. I write this 4, 6, 7, 9 there. Now Super Mario is at number 3. So he can look down here and he can look down there. So 4, 5, 7, 8. Oops. 4, 5, 7, 8. 4, 5, 7, 8. Yeah, happy with that? Now, once I got these things, what I can do is the blue one, the blue number 1 outside. And here you find the 2 by 2 determinant. How? Right-handed. So 9 times 5. You do 9 times 5. 9 times 5 is 45. And then always a minus there. 8 times 6 is 48. Then I got minus 2. 9 times 4 is 36. Oh, red color. 9 times 4 is 36. Minus 7 times 6 is 42. 7 times 6 is 42. Plus 3. 8 times 4 is 32. Minus 7 times 5 is 35. Oh, red color. 32 minus 35. And I will put this in my calculator. The answer, the A determinant for this matrix is 0. This 0 tells us a lot of things. If the A determinant of the matrix is 0, the matrix is known as singular. It's known as singular matrix. If the matrix is singular matrix, the solution does not exist. This one does not have any solution. Solution, no. There is no solution. Yeah. Okay. Okay, so I'd like you to try these questions. Try the question 1. When you try the question 1, there's a tiny trick with that one. I'm just going to show you how to start with. So when you do the A determinant, let's call it matrix B. I'm just going to call that one B. So if I want to find the B determinant, the way it's going to work is first you copy the 3, draw 2 lines. That minus 2 will become now positive 2 because the second one we have to change the sign, and that will be a plus 1. Yeah. So that will be, when you do the 3, you need to do the Super Mario thing. Super Mario is here and here. Minus 1, minus 2, minus 2, 3. So you just got that bit. Yeah. Again, the Super Mario is at minus 2. So if Super Mario is at minus 2, like he can't see here, he can only see here and here. So 3, 3 minus 2, minus 3. So 3, 3. And the last one, if Super Mario is here, 3 minus 1, 3 minus 2. 3 minus 1, 3 minus 2. And then you just actually do the way you do normally. That 3 is there. 3 times minus 1 is a positive 3 minus, that was actually minus 2 there. Minus 2 times minus 2 is positive 4, so that's it. Plus 2. 3 times 3 is minus 9, minus 3 times minus 2 is minus 6. But because there are two minuses here, I can make that one into plus. Plus 1. That times that is minus 6, minus 3 times minus 1 is minus 3. Done. So because there are two minuses here, I can just make them plus. So I got 3 times minus 1 plus 2 times I got 3 minus 3 plus 1 times that will be a minus 3 as well. Okay, so if my answer is minus 12 and this matrix is non-singular. Non-singular means the solution do exist. The solution exists for this one. Now there are the other matrices 2, 3 and 4. I like you to try that later.